Assalamu alaikum kids, this is Ayaz and I'm going to teach you math for grade 7 and it's week 4. Week 4 lecture 4 now. And the topic is the same, other forms of inverse proportion, which you can find in your book 2 on page 29. And as usual, let us recall back about the inverse proportionality. This is a relationship between two or more quantities in which if one increases, other will decrease, or if one decreases, other will increase. This increase or decrease has to be in proportion. Mathematically, it's y2 over y1 is equal to x1 over x2. But remember, it's not exactly the same as direct proportion. In direct proportion, y2 over y1 is going to be x2 over x1. Cross multiplying, you will get an equivalent relationship. x1 y1 is equal to x2 over x2 y2. So, I mean the products of the two values of one quantity is going to be equal to the product of the two values of the other quantity. Is x1 and y1 are the two values of one quantity, and x2 y2 are the two values of the other quantity. And graphically, when you plot y and x, you will get hyperbola. Means the values of y on one axis and values of x on the other axis, you will get hyperbola, a curve, not a straight line. But if you plot the values of y against 1 over x, then you will definitely get a straight line passing through the origin. And here now I'm taking practice now 14, page 32 of your book 2. This is kind of word problem, and as usual, as we have seen in direct proportion, there are physical phenomena, physical laws in which the relationships are either directly proportional or inversely proportional, sometimes square, cube or cube roots, everything is involved in those relationships. So here this is basically Newton's law. If I directly, exactly say here, this is basically Newton's law of gravitation. But anyway, so here the laws is in front of you. This says, in fact, this is a part of the law. It says the force F between two particles is inversely proportional to the square of the distance d between them. When you study the physics, you will see force is basically measured in Newton. This is the unit of the force, and the distance, everybody knows, is measured in centimeter, meters, kilometers, and here it's a dm is basically m is for meter. So this law basically says force is inversely proportional to the square of the distance d. Inverse proportion means 1 over d square, because square of the distance, so d square. And as usual, they have given you one complete pair. When the particles are 2 meters apart, the force between them is 10 Newton. So the force F is given, which is 10 Newton, and the distance d is given, which is 2 meters. And this complete pair is basically we are going to use to find the constant of proportionality. And there are two parts there. One of the parts, first part says we have to find the force when the distance is 5 meters. In the second part, we have to find the distance while the force is 25 Newton. And let's jump on the question. Here is now first we will write the mathematical form of this Newton's law. I say the part of the law, not the complete law here. So F is inversely proportional to d square now. So when we mathematically write it down, it's going to be F is equal to k divided by d square. Remember, it's inversely proportional. It's not directly proportional. So inverse means 1 over. So k over d square. So using the complete pair, t is equal to f is equal to 10. Replacing the value of f and d here, you see, f is equal to 10. In place of d, it's become 2 square. 2 square is 4. So now the value of k is going to be 10 into 4. 4 is divided, on the left side will be multiplied. K is 40 now. So the complete relationship is now of f is equal to 40 over d square. Now the first part is d when the distance is 5 meter apart. What is the force? So in this relationship I replaced d with 5, becomes 5 square. 5 square is 25. So dividing 40 by 25, I get we will get here 1.6 Newton. So it means when the two particles are 5 meter apart, then the force between them is going to be 1.6 Newton. Second part here. So in the second part, force is 25 Newton. We have to find the distance, how far the particles were when the force between them was 25 Newton. So replacing again the value of force now, F now 25, you could see on the screen. So I need the value of D. So from D from the right side, I brought it on the left side. It will be multiplied on the left now. And 25, I took it, brought it on the right side. So it will be divided on the right side. So dividing it, you got 1.6. Now I need D. So how I remove this square? I will take the square root on both sides. So taking square root on both sides is in front of you, and this in brackets say d greater than 0, greater than mean positive. I am taking here d positive. That's why I didn't write plus minus sign over there. But you remember when you take the square root, there's always two values, plus minus. So we are just taking the positive value of d. So that's why it's this is written d greater than 0 here. So square root will be cancelled with the square. So we got d, and the square root of 1.6 is 1.26, and it says up to 3 significant figures. So you have studied in grade 5 basically. What is the meaning of significant figures? It means is here 3. I took just because when you take the square root of 1.6, it's going to be long answer over there after the dot. So we just remove that one. I just took 2 digits after the dot. All together becomes 3. 1, 2, and 6. 3 digits over here. So the answer is here now. When the particles are 1.26 meter apart, the force between them is going to be 25 Newton. And here I took now one more question from your exercise 1D. This is question number 7, and I think it's a little bit difficult for you guys. That's why I'm trying to explain it to you now here. The question statement says basically this is again the same Newton's law of gravitation involved here. The parameter is a little bit different now. Same, it says the force F is basically inversely proportional to the square of the distance d between the two particles. Law is the same, but the scenario is a little bit different now. First part, it says we have to write down the formula or the equation connecting F and D, which we already done in the previous practice now. And the second part, it says when the particles, the distance between the particles is certain, the force of repulsion between them is 20 Newton. Okay, but the question here is find the force when the distance is halved. Means whatever the distance, this certain distance, whatever the distance was, when we make that distance half, means we brought the particles closer. For example, if the distance between the two particles is, let's say, 1 meter, the force is 20 Newton. What will happen with the force if we brought the particles to half meter apart? and the distance between them is 0.5 meter. So then what will be the force? That was the question. Let's start it. First part is very simple. F is inversely proportional to d square. So mathematically we will write it down. F is equal to k divided by d square. K is a constant. We're done with the first part. Second part is a little bit tricky. Let's see now. Here it is. Force, it says force F is 20 Newton, and in the question it says there is a certain distance between these two particles when the force F is 20 Newton. And let's assume that certain distance between the particles is x meter. Okay, in that case the relationship becomes force is 20. I replace 20 in place of F, and in place of D I replaces X here. I hope you're understanding, you are with me now. Force F is 20 while the distance is X meter. So in place of D I put X here. We don't know that certain distance, but there was a certain distance when the force is 20 Newton. So we assumed that distance between the particle is x meter when the force is 20 Newton. So okay, I'm playing with it. K is equal to 20x square. The value of K is equal to 20. X is divided on the right side, go on the left, it becomes multiplied. So K is 20x square. So now I'm replacing the value of K here. So F is equal to 20x square divided by D square. Okay, now in the same part it says what will happen with the force if we brought the two particles half of the distance what was in case of 20 Newton force, as I told you. So we assumed here that certain distance is x meter. So now we are making half of that x. So you could see d is equal to 1 by 2x, half of the distance, whatever that distance was, 2 meter, 1 meter, 10 meter. It was 10 meter, it becomes 5 meter here. It was 2 meter, it becomes 1 meter here. So let's replace that d 1 by 2x in that relationship, above relationship. So 20x squared divided by, in place of d I replace 1 by 2x. Remember d square, so square is there. So taking the square of 1 by 2x, 1 square is 1, 2 square is 4, x power 2 becomes x square. So when I change the division sign, the main big division line, into multiplication, this 1 over x square will become upside down. 4 goes up and x square goes down. So x square will be cancelled. 4 multiplied by 20, it will give you 80. So F is equal to 80. Force is 80 Newton. Means when you make that certain distance half, the force will become 80 Newton. From 20 Newton it becomes 80 Newton. Mean the distance as the particles comes closer, the force become bigger and bigger. In other words, you can also see force 20 to 80 means, going up to 80 means it's become 4 times. 20 plus 20 plus 20 plus 20, 4 times. So making the distance half, the force becomes 4 times. That's the kind of you can say explanation. You can say the word problem. Okay, so mathematically we're done with this. And as usual, champs, it's your turn to judge how much you got. So you should take a short break here, pause your video for a while, go to your book 2, page 32. There is a solved example 14. So read that example carefully. There's a word problem. Don't get confused with the long statement. Get the actual material out of it. It's solved there. Go through each and every step and then come back. Okay, as usual, I hope that example has helped you out a little bit more in the understanding of the topic. And here's your fourth assignment now, which is just one question, exercise 1D, question number 8. Remember, it's going to be pretty much similar to what we have done in the practice now 14, and a little bit helpful for the question number 7 also to you guys. I'm waiting for your responses, and goodbye, take care, thank you.